So today I'm going to talk about real-time machine learning visualizations with Spark. So the first, he briefly introduced, I'm the director of engineering at Alpine Data. So I'm also the founder organizers of this meetup called San Francisco Big Analytics. Currently we have close to 4,200 members. Previously I have working from big and small companies from places. I've been poking around the Spark since Spark 0.6. So, but mainly most of the work is really at Alpine, where we did a lot of integrations with the Spark from 1.1, 1.3, 1.5. Currently we're on the 1.5.2. So, and Alpine runs on different Hadoop distributions. And so, for example, different version of Cloudera, Hortonworks, and the MapRs. And we also support pivotals and all that, and big insights and all that stuff. So just one slide on Alpine. So Alpine is a predictive analytics platform for enterprise. So we've been working, we have this visual UI allow you to drag and drops to do analytics on it. And we have a management piece allow you to managing the relationships between data science and tracking the workflows. So in particular related to Spark, and we are the first one being certified on the advanced analytics on Spark. So I don't need to talk about what is Spark. So, okay, so, before I jump into the real-time visualization for this machine learning, so I want to quickly just go through very simple machine learning algorithms. And I know this is probably just for many of you already know this, but I just want to have one simple thing so we're on the same page. So this is, in this case, we're talking about k-means. So in this diagram, so we see a k-mean with the 3 clusters. And I'm using this publicly available data sets called ARIS datasets. So, so here we have 3 clusters, cluster 0, 1, and 2. And the big dots in the middle of the cluster is called centroid. So, so the k-means really just try to find the optimum distance, which the distance is measured between the centroid to the any points of the data set. So what exactly the k-means? And if you look at the Wikipedia, essentially find the distance and try to minimize the distance, find the centroid and then try to minimize the distance to the clusters, so to each point. And there's a mathematical equation so you can find out and then try to minimize that. So given that, so for each calculations of a machine learning optimizations, essentially there's a cost function goes with it. The cost, here's the plots, the cost versus the iterations. So if you see the cost essentially after certain points, mostly plateaued, even though they're gradually decreasing. But pretty much if you're experimenting with the machine learning, you probably want to say, okay, after 10 iterations, I think that's good enough. So I can want to stop. So you want to see how the cost function gradually comes down. So this is the work we talk about. So, so the real-time machine learning visualizations, why we want to do that. We need a way to visualize the machine learning training process, including convergence, clustering, residual plots, or if you see the cost has pretty much plateaued, you want to stop the iterations, just gather the model then, and then maybe try some other variations, other models. Or you want to say, okay, this is good enough, I've seen enough of this, just disable the visualization, don't cause taking more time, just let it finish. So there's a way, things you want to do. So with that, I want to quickly do a demo. So this is a quick time video I pre-recorded because I don't know the internet connections and all that stuff. So give me a second. Put this here. So here's what the Alpine, workflow engine looks like. I directly put this to work in the Alpine product, so I can quickly show this. So basically you can drag, say for example, a file or tables or whatever, Hive tables, database tables, and in this, or Hadoop tables, Hadoop files. So we drag there, and we usually do some variable cleaning and some variable substitutions, and then eventually do some transformation, and then you connect to a machine learning algorithms. In this case, I just directly connect to a k-mean, and so because I wanted to do a quick demo. So let's quickly run it, and I want to show. So here, let me stop here a second. So here you can see the data sets. I don't know if you can see it. It's pretty small. The file size is about 10 gig, and I'll just double click the properties so you can see that I set the max iteration is about 20. It's too small, so just believe me. So and I'll let it run. So I'll let it run fast. So I make it really. So we, you notice that there's the tracking URLs you can click, and then we can bring either the log or the Spark UIs. So here I put two views side by side. So yeah, maybe I run it a little bit faster. Things will happen after. So because initially the Spark started to launch the jobs and then so the machine learning haven't really hit it yet. So it's, well, I think maybe another, let me make it a little faster. Okay, all right, so let's make it normal speed. So I'm probably running too fast, but essentially at a certain points we see that the data start to come in, and then the cost functions starting plateaued. And we have two views against the two different plots. And I think the first one is this is the airline data. So basically it's departure time versus arrival time. So the other one is the distance versus arrival time. So you can plot different clusters, and then the centroids will see that. But in this case, because it's pretty much plateaued after certain points, and you can click stop there, and then that will stop the iteration just to gather the stuff here. You notice here, when I click stop, the log basically print out and say, hey, stop equal to true, and so iterations, the message being passed to the Spark will come back. So this kind of, let me just quickly let it go to the end. So we also have a sliding bars. So essentially allow you to slide back and forth. You can, if you want to replay the see how the centroid actually removed. You want to see it again and allow you to do that. Because once it's plateaued, the centroid is pretty much not moving. It's only at the beginning, the centroid moves. So that's kind of the demo. So with that, let me close this, go back to our presentation. Okay, so how do we do that? So essentially, how do we enable this real-time visualization? So because that's just a demo. So if you say, hey, if I want to myself in our system, not in Alpine, so what's the necessary steps you can make this happen? So essentially, you need 4 parts. First one is a callback interface in the Spark machine learning algorithms to send messages. And the algorithm will decide what to send. In the k-means case, where you send centroid, you may send in the sample data. But he doesn't know how the message got delivered. He don't care. And so he say, here's the message, send it over. The second part is a test channel to handle message deliveries. In this case, it's from Spark driver to the Spark client. In this case, the test channel, his only job is basically deliver the message. He doesn't care what the message is. So, and once the message is delivered to the Spark client, and basically who's submitting the jobs, we basically send the message to the browser. And in this case, we're using a push to send to browsers. And we'll discuss push and pull later. But basically right now it's a push to the browser. And the browser, and then using visualization frameworks to display them. For example, in this case, we're using Plotly and D3. So we're diving each different parts. So okay, so first, in the Spark job, in our case, we basically run the young cluster mode. So so that's the case because different clients are running the Spark job, so we don't want to crash them. One person to crash, bring the other one down. So basically, it's on the cluster mode. So in the cluster mode, the Spark job, you have a Spark context, and the Spark driver is inside the container. So the Spark clients is really our application code is sending the job over, and the the request can come in from command line, a REST API, or servlet applications like a Tomcat and Jetty. In our case, it's a Jetty applications and send it over. So we create an application context. There's additional context we create because we control how the Spark job is invoked. So we create an application context, and there we set up the communications. Oh, 10 minutes? Okay, all right. I'll speak faster. So that we send the communication channels and the loggers, and then the machine learning algorithms, directly call the machine learning listener interface and send a message over. So, and the message is sent back to the application server through Akka messages, and eventually we're using this chunked response, send it over. All right, so let's get into the listener part. So it's actually quite simple interface. For example, we define an interface called a machine learning listener. So it has a simple signature called onMessage, and the message is passing over. And the other interface is ML listener support. Basically, when you send send message, you pass whatever messages. If the listener is enabled, we basically just call onMessage for each listener. For k-means, we essentially modify the k-mean code, basically mixing that listener support interface we mentioned earlier. And for concrete message we send, in this case, we define essentially a case class with the essential iterations, the centroid, and the cost values. And there, we simply modify this run algorithms. If you look at the k-means code, essentially come down to this method called run algorithms. This is all the Spark code. And the only part which is bold is I modified. So essentially, if it's not stopping, and basically we send in the messages. And the messages is really just the case class we mentioned earlier. So remember the ML listener is just an interface. So for the k-mean specific, and here we essentially, this is a little bit more code, probably than you expected. But essentially the idea here is, at the beginning we sample, we take the RDD and then take a sample and of the data. And from that sample, since at this point we already know we got the message for the centroid. And then we're basically using that sample to predict in the model to predict what the cluster is, and then send this information back to the browsers. So how do we set it up? So there's the only difference is if you call the k-mean is, instead of call new k-means, you call new k-mean extensions, you add the listeners. And then we also notice here, we also add something called a task observer. I will describe it later. And that's the interface receiving commands. So the task observers, unlike the listeners who's basically sending message out, here basically receiving messages. And in this case, we basically want to receive a message like, for example, you want to stop the visualization or stop the iterations. And so you can collect the information. So, and the task observer is, again, a very simple interface which have only one method, say notify, and then you can implement different ones. So I'm going to skip logistic regressions. So I'm going to talk about task channels. So so we described the first part of the message has been sent it out from machine learning to somewhere, and it's who's delivered them. So in this case, we have this task channels. So when the Spark application starts, we mentioned that we create this application context. In this case, we're using Akka. So we create a new Akka systems. The Akka system creating two actors. One is for messaging actor. The other one is task channel actor. The one is sending message out. The other one is receiving messages. And then we also create a Spark context to do the normal Spark jobs. Okay, so here's the picture. So the k-means, for example, sending messages through ML listeners and then sending it over to the logger. Essentially, that's the messaging actor who's sending the Akka message back. And then if you're sending a message over to the phrase stop, it'll go to the task channels and then go to the ML listener in turn, change the flag, and then the machine learning will stop. So, okay, so that describes the second part. The third part is to say, how do we push the stuff to browser? So again, we're sending Akka message here. So we're using this HTML5 server send event, SSE. Is a one-way messaging. So you can register this event source through the URL on the JavaScript side, and then there's a callback and say on message you pass whatever functions. The data format specific for SSE is you have the data colon, and you can just put a JSON string there directly. And on the server side, since we're using Akka, okay, using Akka, we're using Spray-based REST API server. So the Spray is an Akka-based server. So you can have this chunk response support. So in this case, each time we got a message, essentially we start a chunk response and just keeping sending, and then until we got everything finished. So I guess we can describe this. I can skip this. So the last one is the visualization. So here we just using Plotly, and using Plotly to plot the visualization is actually quite simple. So you define your cost vectors in a data vectors, and eventually you specify the x and y's, and and they just plug into JavaScript call. And Plotly is open source; everybody can use it. So quick in summary, since I only have like a minute or two left. Training machine learning visualization involves a lot of experiments, so we need a way to visualize the process. And for Spark, especially Spark Young Cluster Mode, essentially a batch job. You have no clue what's going on until the job finishes. So with our approach, this gave you a way to essentially do a callback to your system to allow you to actually see what's going on. And the approach I described is not a really, it's not complex at all. So pretty much everybody can implement this. So I guess thank you. And here's if you want to later on look at the the presentation, the demos, and linking pages, it has all the information. Thank you very much. Still have time for questions?
Yeah, plenty of time for questions.
Okay, all right. So any questions? Sure.
Can you share something about the impact that the real-time visualization for machine learning in your company or for your customers?
This is actually a new feature we put. Where customer haven't really used this, so for many of our data scientists, they basically want to see, if I running a job is pretty long, what's going on? So that would be first things I want to see. So we implement 3 algorithms essentially for k-means, logistic regression, and linear regressions. And I skipped through the linear and logistic regression part. And essentially, they basically say, if I gave a set of iterations or a set of is this already converged? If it is converged, why bother waiting for that? And because I want to try either different models or different parameters. So this will give you a quick way to do that. All right, thank you very much.